Hi everyone and welcome to today's Physics Daily Booster. This is number 4 in our series and it is one of the advanced listed topics. This time it is listed on both foundation and higher tier, so it's section 2.1 in the specification that we are looking at today. What we're going to be looking at then are a few key calculations and types of graph that we need to do, all to do with movement basically. It might seem really obvious to start with this, but this question comes up. They will ask you what bit of equipment you can use to measure distance or time. In terms of measuring distance, a ruler is absolutely perfect, and in terms of measuring time, a stopwatch is a great answer. Don't forget that we can upgrade our stopwatch to a light gate. So if we're talking about any experiments where we're using a stopwatch for something moving, a light gate is an improvement because it removes that whole human judgment side of things. We could, if we've got a load of fancy equipment, use ultrasound to measure distance, because what it does is it sends a little pulse out and then it's going to record the time it takes for that pulse to be reaching back to our sensor. So basically it sends the pulse out, reflects off something, and then it records the time and just does speed is distance divided by time calculations there. That brings us very nicely onto the first calculation we could be asked to do in this. As we already know, we are getting all of the formulas on our formula sheet in the exam, so you don't have to memorize any. We just need to remember it's there and use the right one. So what we've got, speed is distance divided by time. Do watch out to make sure the distance is in meters because they might give it to you in centimeters. To convert that, divide by 100. Nice and simple. There are two terms that we need to know when we're talking about motion. First is vector, and this is something that has a direction and a magnitude or a size. Good example of where we've encountered these before is in forces. Second one is a scalar. And this is a quantity that's got a magnitude or a size, but it has no direction. So time, for example, is a scalar, whereas forces are vectors. If we apply that to our particular context of moving things, then we would talk about distance being a scalar quantity because it's just how far you've gone, whereas displacement is a vector quantity because it tells you how far you've gone in a certain direction. So you'd need to include the distance and the direction for that. If we then apply that to our speed and velocity, two terms that people seem to think are interchangeable, they are not. Speed is how fast an object travels, scalar. Velocity, how fast something travels in a given direction, vector. So just remember the difference between scalars and vectors. Don't forget that we would have positive values and negative values if we've got a vector quantity in opposite directions to each other. One would be positive, the other would be negative. The next term we need to understand is the word acceleration. Now, acceleration, quite simply, is the change in velocity per second. Formula on the formula sheet to calculate it, change in velocity divided by the time. Just remember to check the time is in seconds for this one. Sometimes they could give it to you in hours or minutes, so you may need to convert. Because when we talk about acceleration, it could either be positive or negative, then what we would actually have is an increase in velocity, positive, or a decrease in velocity, negative. So again, we would have positive or negative signs there. And one number that you really should try to learn here, the acceleration due to gravity here on Earth is 9.81 meters per second squared, or they would accept 10. But 9.81 is better because it's more accurate. We need to understand two types of graphs to represent motion. The first is our distance time graph. There are 4 key parts to know on a distance time graph. First, a horizontal line means the object is stationary, is not moving. A diagonal line means it's moving at a steady speed. Curved lines is moving at a changing speed. And then if we actually want to calculate the speed, it's the gradient of the line. So if they were to ask you to calculate the speed between 5 seconds and 10 seconds, then all we would do is just draw our little right angle triangle underneath. So if this little dot here, let's say it's 5 seconds, it's a terrible triangle, I apologise, to 10 seconds. You draw your little triangle using a ruler, of course, so we end up with nice clear lines. then you work out your little values for A and B. So work out the difference there in the distance, the difference in the time, and then all you do is distance divided by time, so A divided by B. That obviously gives you the nice simple speed. The only way you will know whether you have a distance time graph or something else is by looking at the labels on the two axes. So do look carefully. We can have displacement time graphs, but remember the difference between distance and displacement. Distance is just going to be a scalar quantity, has no direction associated. Displacement is a vector, has direction. So even though these two graphs on the left are showing the exact same journey, then what we get is a different shaped graph, because what we're actually saying here is an object is traveling away initially, then it's going to be stopped for a while before returning home. So on displacement, what we can see is we've got obviously that diagonal line going in one direction as it moves away from the start point, and the diagonal line coming back as it returns. Distance, however, is just the total distance it goes, the direction is irrelevant, so it just keeps counting up. Our next two graphs are speed and velocity time graphs. Again, the only way you can tell the difference is by looking at the label on the y-axis. Both of these graphs again show the same motion of the same ball, but what we can see is speed is scalar, therefore it does not take the direction into consideration. Velocity is a vector, so it does. Hence why we've got both positive and negative values on that graph. As far as our velocity time graph goes, then we've got four key features we need to know. The horizontal line in this case means that the object is travelling at a constant velocity. A diagonal line means a constant acceleration, curved line a changing acceleration, and if you want to work out the acceleration, just calculate the gradient of the line. The same way we did before, draw your little triangle on here where it tells you, so whatever your times are, and then you can just do your two values, A divided by B. They could ask you to calculate distance or displacement, depending on which type of graph they give you. And quite simply, it's just the area under the graph. Now, I don't suggest you try to do this by using any complex formulas, because any shape they give you will be divided up into either triangles or rectangles. So if we were to be trying to do this for the green line, we would divide it up into our two triangles and the rectangle. So work out your areas of the two triangles, and then you would add it to your rectangle. So what we have is the area of triangle plus the area of the second triangle plus the area of the rectangle gives us the total, in this case, displacement, because it is a velocity time graph. One of the other formulas that you could be asked to use is this one, again listed on our formula sheet, don't have to memorize any. So final velocity squared minus the initial velocity squared is 2 times acceleration times the distance. This is more a case of look and see what information you've got to work out which of the formulas you need to use. So if you've obviously got a final velocity, an initial velocity and a distance, we can actually use this to calculate acceleration. So do look at the question to work out whether this is the one you need to use or whether there's an alternative formula to use. Our final calculation for this little booster is all to do with kinetic energy. What we actually have then is its energy, therefore the units will be joules again, and kinetic energy is all to do with movement. So what we actually find is to calculate your kinetic energy of any particular object is 0.5 times the mass times the speed squared. Two key things to look for here. First, is the mass in kilograms? If they've given you mass in grams, convert to kilograms first by dividing by 1,000. Secondly, remember to square just the speed. People frequently misuse their calculator and end up squaring the whole thing. Square the speed first of all, then times the mass, then times 0.5 to make sure you get the right answer is my advice. Final thing to do for today then is head on over and have a go at the quiz. Obviously, if there are bits in today's booster that you're not 100% certain on, then you can use the videos on the main channel to support you. Obviously, just search whatever the topic is, or you've got your revision guides, your actual classwork notes, use those to help you out. Don't forget to join us again tomorrow for our next daily booster.